So good afternoon, ladies and gentlemen. It's my pleasure to give you today a webinar about the photovoltaic or the applications of solar systems in our homes. Now, from now on, when we say solar, I mean photovoltaic here. There is a difference between the solar systems and the photovoltaic systems. We have here two categories. The solar could be thermal or could be photovoltaic. In our webinar today, we'll be talking about the solar photovoltaic type. The solar photovoltaic, as you know, converts the radiation to electricity, while the thermal convert the heat to electricity. So there is a difference between the two categories. My name is Anas Al-Tarabshi, Associate Professor in the Electrical and Computer Engineering Department at Abu Dhabi University. My field is electronic devices, semiconductor materials, and renewable energy. So I hope you will enjoy this webinar. If you have any questions, you can ask me at the end of this webinar, please. Good. Now we start today by a good fact, which is in 1 hour, the amount of power from the sun that strikes the earth is more than the entire world consumes in a year. Which the idea behind that the photovoltaic has a good potential, okay, and it can cover all the needs of the whole world. Good. Now the webinar starts with the fabrication of the solar cells. I call it sand to cell. And then I'll be talking about the PV technologies, their types, and the differences between them, and the potential of photovoltaic in the UAE, and the vision of the UAE for the renewable energy field, and the energy usage in our homes, and then the PV systems, how we design the PV systems for our home. So you can take this exercise for your own home and you can design it in simple steps. And then I would like to share with you our students' success stories. Okay. We start first by the sand to cell. So here the silica in the sand is converted to silicon by chemical reaction with carbon to purify that silicon. So we get about 98% purity. And this amount or this percentage is not enough to fabricate the photovoltaic and semiconductor materials. We have to purify it more and more with extra chemical reactions to get a semiconductor layer. Now, the semiconductor layers could be either intrinsic, that means pure silicon, or they could be extrinsic. The extrinsic could be a p-type, that means we add some boron atoms, or it could be n-type, that means we add some phosphorus atoms. Those atoms are added to enhance the performance and the conductivity of the silicon materials. Now, when the two materials are adjoined to each other, I mean the p-type and the n-type, right now we have a device. So take it as a rule, to have an electronic device, we have to have at least two different semiconductor materials. Okay, now we have front contacts. Let me just, okay, here we have the front contact and here we have the back contacts, okay, and in between we have the semiconductor material. So this is the main structure of the solar cells. Good. Now the solar cell here doesn't generate that high power. So how can we increase the power? This cell should be combined with other cells, either in series or in parallel. Okay. Now in series, the voltage will be boosted, while in parallel, the current will be boosted. Good. Now the module here can be connected to batteries, inverters, protection system to have at the end a PV system. Okay, now what are the most efficient PV panel manufacturers right now? Actually, this table shows the best manufacturers for the last year and this year. Okay, so as we see, the top 3 companies, which are the SunPower, the LG and the RIC companies have the first three or the top three companies. So the message behind this slide, to buy PV modules, we have to use or we have to consult with good companies. So as we see here, some companies were good in the last year, right now, or in this year, they are not in the list. So as we see for the sun power, the highest efficiency reached about 22.6% for a module that generates about 400 watt. Okay. Okay. Now we start right now with the PV technologies. We have monocrystalline cell or monocrystalline module. We have polycrystalline cell and we have polycrystalline module, and we have thin film cells and we have thin film modules. The main difference here is how the atoms are arranged within the material itself. So in the monocrystalline, the atoms are very well arranged. I mean, in all directions, in the X, Y, and Z directions, all the atoms are very well ordered, and even the length between the atoms is the same. The strength of the bond between the atoms is the same as well. So this is why we get highest efficiency for this type. Now for the second one, which is in the middle, which is the polycrystalline here. Now the order is not that uniform like the first one. So this is why if you look up here at the cell, you have different reflections. That means the atoms are not very ordered in all directions. Or in all positions here, you have some areas where the atoms have some pattern, which is different than the pattern in different areas. Now, in the thin film, the technology is a little bit different. First of all, the fabrication is done at low temperature, and the fabrication is done at thin film, or sorry, at flexible plastics or flexible foils. The efficiency will be less than the polycrystalline, and the efficiency of the polycrystalline is less than the monocrystalline. Of course, there are other technologies, but here I have shown the top three technologies that are needed to power and meet our energy needs for our homes. Okay. Now you may ask yourself right now, what is the best type of PV modules for our homes? Now, while asking ourselves this question, first of all, we have to think about the parameters by which we will select. First of all, the cost of the technology or the cost of the PV module. The second figure of merit is the output power. The third figure of merit is the space. I mean here, does the available space on our roof accommodate the whole number of modules? And we have important figure of merit, which is the durability. Now, what I mean by the durability here, that the efficiency, of course, decreases by time. Okay, so it's not enough only to look at the current efficiency when you buy the modules. We have to look at the data sheet, okay, that says after 25 years, what will be the efficiency after this time lapsed. Okay. Now, if you don't have a wide area on your roof, you can choose the crystalline PV modules because they are the best among the others. If the size really matters, then we have to go to the highest rated PV modules. Okay, why is that? Because the small size of PV modules can have different ratings. For example, 100 watt, 150, 100, 200, and could be more. So the tip here, don't try to go with the cheap PV modules. Otherwise, you'll be having to pay it again. Now, what about the potential of PV in the UAE? Okay, now as you know, the radiation increases from at the sunrise and becomes peak almost at noon and becomes minimum at the sunset. Now, actually, this pattern or this curve changes by time, by date, and also it's geographical location dependent. So to unify all our calculations, and since we are interested in the energy because what we pay at the end of the month, we pay for the energy, not for the power. And the energy, as you know, is the integration or the area under this curve. So if we have this rectangular that has the same area of the left-hand side one, in this case, we can say the two energies or the two curves have the same area, or we can say the two have the same energy. Now, how to find the energy? It's very simple. The area under the curve or the area in this rectangular. So just you multiply 1 kilowatt by this width. Now, this width from now on will be called as the peaks and hours. Okay, so let us say right now we have 1 kilowatt of PV modules installed in our roof. How much energy can we produce from this example, assuming the location in Abu Dhabi? So what we have to do here, first of all, we have to look at the location where the modules will be installed, okay? And we look at this bar. Now this bar here, we have the upper numbers as you see, and we have lower numbers. The upper numbers show the peaks and hours. For example, if you take any location here, you can find the corresponding color. So I'll be taking the average about 5.5, okay? So 5.5 hours, when we multiply it by, and here 5.5 times 1 kilowatt, you'll get what? 5.5 kilowatt hour. This is in one day. Now, what about in 1 month? It will be 165 kilowatt hour per month. Or if you like to convert it to kilowatt per year, it's going to be about 2,000 kilowatt hour per year. That means here, if we have 1 kilowatt peak of PV modules, this system will generate about 2,000 kilowatt hour in 1 year. Okay. Now here I'll give you example for the whole current, for the whole country here. The question here, can we design or can we calculate how much solar energy do we need to cover the whole country needs? We can answer this question by knowing, or by knowing here how much the energy consumption in the UAE. So here I found the consumption about 113 billion kilowatt hour per year. Now, assuming the peak sun hour, or we can call it the insolation value, or the peak sun hour, 5.5. Okay, now if we divide the consumption over the generation, and here I'll be assuming the efficiency of the modules, or not the modules, the whole system, including the modules, the energy losses in the cables, the inverters, the batteries, whatever you like. I assume that efficiency as 15%. Doing so, without going in this equation, we need about 380 kilometers square of the PV panels. Okay. Now, this corresponds to 20 kilometer, almost by 20 kilometer of PV panels. We can cover the whole needs of the UAE. Now, this 380 kilometers square shares about 0.5% of the whole country's area. Okay. Good. Now, the UAE Vision here, in 2050, the renewable energy should share about 44%. Okay. Now, from the gas, it's going to be about 38%, while from the clean fossil, about 12%, from the nuclear energy, 6%. Okay. Now, the plan will increase the contribution of the clean energy up to 50% by 2050. And it will reduce the carbon emission by 70% and will improve the energy efficiency by 40%. And it will increase the savings by 700 billion. This is assuming that the annual growth demand is about 6%. Okay. Now, what about the energy usage? Or how can we, what about our pattern or attitude for the energy consumption? Now, this graph here shows a very simple pattern, okay, for the energy consumption for one of the homes. It could be different from home to home, okay? it could be different from day to day, but this is an example. So here, the idea behind this example, that there are some time slots where the consumption is high, and there are some other time slots where the consumption is reasonable or the consumption is constant. As a matter of fact, here, about 50% of the consumption goes to the heating and the cooling, while 13% goes to the water heating, 10% for the lighting, 7% for the electronics, 6% for the clothes washer, 5% for the refrigerators, and the 2% for the dishwashers, and 8% for the other. Okay. Now, this is a very good point here. Before we install our renewable energy system with less efficient appliances, we have to install what energy efficient appliances. So we have to think about the energy efficiency. What do you mean by that? Now, first of all, the first part of the energy efficiency is called applying energy efficient equipment here. That means we can include timers, okay? And those timers will turn off the devices after a specific time. We can include other devices like occupancy sensors, the infrared and the ultrasonic sensors, okay? The second point of the energy efficiency covers the changing our energy use habits, which means we have to change our culture and habits to turn off any device which is not in operation. Okay, the second point in changing the energy use habits is called the eliminate the phantom loads. Now, the phantom load here is any load that's connected to the grid while it's not in operation. For example, if the TV is off while it's plugged in the grid, okay, it consumes some energy. And you can, by the way, you can feel it if you can hear some noise, okay, when you come closer to the device. Okay, now it was found that about 7% of your electricity bill, okay, goes for the phantom load. You can take this as an exercise to you. You can look at your energy bill for this month and assume that this is the average for the whole year, or you can look at the energy bills for the last 12 months, multiply that number by 7%. That 7% is because the phantom load. I'm sure you will be finding that amount as reasonable amount. Okay, so just to summarize here, applying efficient or energy efficient equipment with changing our energy use, this means what? The energy efficiency. So this is the definition of the energy efficiency. Perfect. Okay, now we start with the PV systems, types of PV systems, how we design the PV systems for our homes. The first type of the solar energy systems is called the off-grid, or some people call it standalone, where the systems are completely independent of the utility grid. They require batteries here to store the energy they collect during the operation. So this is the main structure of these off-grid systems. Here, those are the modules. The modules can be connected in series to increase the voltage and can be connected in parallel to increase the current. All in all, we can increase the power, okay? Good. Now, then we have a charge controller to control the charging and discharging process of the battery. We have an inverter that converts the DC power from the PV system here to an AC. Okay, because here we have some loads that operate at AC and we have some loads operate at DC. This is the main structure of the off-grid system. Of course, we have fuses and we have protection in the system here to protect the PV modules from the flowing back the current to the modules. And also we have some what's called bypass diodes to mitigate the shading effects on the modules. But what I mean here, those are the main components of any off-grid system. This is for the off-grid. Now the second type is the grid connected, or you can call it a grid tied or net metered PV systems. Now the main difference for this type that we eliminate the batteries. Why is that? Because the storage right now becomes the utility grid itself. So this is the main structure of any on-grid system. So here we don't have batteries in the system. Of course, here we have a meter that counts how much energy is generated and how much energy is consumed by the grid. At the end of the month and at the end of the year, you can find whether you have surplus energy, okay, to pay, or you can, you can sell it for the company at the end. Those, again, the main components of any on-grid systems. We have the source, the PV modules, which are connected in series and parallel, as we said before. We have the photovoltaic array combiner, okay, that combines all the cables in one small box. We have cables, which we call them DC cabling before the inverter. Between the PV and the inverter, everything is called DC. After the inverter, everything is called AC. So we have DC cabling, we have AC cabling, and we have them. This is the heart, or this is the brain of the whole system, which is the inverter. And of course, we have here meter to calculate the energy generated and consumed. Now, the question here, how can we design and calculate the PV system size for our own homes? The good news, we have simulation programs. So you have to be familiar with such programs or such simulators. We have PV chart, we have PV Syst. This is one of the most important simulator that is used by many companies. We have PV Sol as well, is very important. We have PV Case, PV Planner, Hammer, and Sunny Design. Okay. Now, today I want to show you simple calculations without going in details in such simulation. From where should we start? We have to start from our load. So we look at our load. I call it here load estimation. After we find and calculate our load, then we calculate the PV panels needed. Then the battery and the charge controller needed. Then the inverter needed. And at the end, we can find the losses and the cost estimation of the whole system designed here. Okay, good. Now, here are some examples of the appliances that we have at home. So what we need here, we need the power of each device that we have and how many hours that device is operating daily. For example, you can take advantage of this table and you can take the numbers, the wattage or the power of each device here. Okay, so here we have different devices that we can have at home. Here we have other devices. Okay, good. Now, once we know our devices here, we have to know how many hours is that device operating daily and monthly at the end. Okay. So this is, for example, this is a very simple example. You can look at the appliances that you have at home and the power rating. You can take them from the table that we already explained here. And you can take this exercise for your home today, by the way. So please take this exercise to find or to design simple PV system for your own home. Okay, so you look at the rating and then you multiply the rating of the device by how many devices that you have. For example, here, if we have 4 LEDs or 4 light lamps, and the rating of each lamp is 7 watt, then here it's going to be 28 watt for consumption of this or of those 4 lamps. Then how many hours we use that device or those devices. Then you multiply, guys, the power times the time, you'll get here what? The energy. Then you add all the energies, or you add those numbers, okay, you get this number, okay, which is 2,326 watt hour. Okay, so this is our energy need. So we are done with the load estimate. Right now, we start with the PV panel estimate. Now you can take any PV module available in the market, and as I told you before, we have to select good modules. Okay. Now, once the module is selected, we have to take the data or the numbers from the data sheet, okay, to find how much energy can be produced by such modules. Okay, so without going in details here, it's very simple. What you can do here, you can go back here. You can look. You can go to the slide before. Which is here. Okay. So this is guys, this is the energy needed. Perfect. Then taking into account the losses, and here the efficiencies of the inverter, the batteries, and the charge controller, we need about 2,771 watt-hour. Okay. Now after that, you divide this number by how many hours, what's the peak sun hour in the UAE. You can here use 5.5. Then you'll get 461.9 watt. Okay, good. Now we divide this watt by voltage to get how many amperes we need. So here, for example, we get 38.5 ampere. Now this is, guys, this is what we need from the solar system. Now, based on the module that has been selected, we look at the current, which is here. Where is it? The current 8.54. You divide 38.5 over this current, you will get here what? You will get how many modules in parallel. So you'll get here 4. Okay. Now, since the voltage selected 12 volt, that means one module in series will be enough. My point is, we need right now 4 PV modules to cover the energy need of this example. Okay. Now, normally we multiply the number of modules by their price. Normally we say $0.8 per watt. So here it's going to be about 432 watt for the modules. So we are done with the load. We are done with the PV panel. And right now, we'll be talking about the battery. Again, here we can use the available batteries in the market. And keep in mind, right now we have 6 volt in the market. We have a 12, 24, 48. Since the voltage system is chosen to be 12 volt, okay, that means we can use the 12 volt available here. Now, if you like to choose the 6 volt, that means in this case we have to connect the 2 cells in series, the 6 volt with the 6 volt in series to get the 12 volt. Since the battery is chosen here 12 volt, that means one battery in series will be enough. Okay. Now, how to find how many batteries are needed? We divide the watt hour and we take the safe factor here. You can take this value, by the way, the safe factor. You divide the watt hour over the voltage. What's the voltage? 12 volt. Okay. Then you get here this ampere hour. You divide this ampere hour by the ampere hour of your selected battery. Okay. And you round the value. Then here you'll get 4 batteries. 4 batteries in parallel. Then you find how much those batteries cost you. Okay, good. So we are done right now with the batteries. Okay, and right now the charge controller. The charge controller is very simple here. Once the charge controller deal with the 12 volt, you can use it easily. But please try to find the highest efficiency available in the market. Okay, and keep in mind that this current, should be greater than the current that can be generated from the PV module, just to protect the device from being, just to make it in the range where this charge controller has a maximum current of 45. That means any current that fit to this charge controller should be less than 45 ampere. Okay. So this is how we choose the charge controller. The voltage should be compatible with the voltage, and the current should be greater than the current generated by the PV modules. Okay, so we are done with the charge controller. Right now, you can look at the inverter. The inverter, as you know, converts the DC power to AC power. The highest the efficiency, the better the inverter. Right now in the market, you can find inverters that have about 98%, about 98.5%. Okay, good. And the inverter here should generate pure sine wave signal, such that we don't have harmonics or we don't have noise added to the generated current. And also the frequency should match the frequency of what? Of the grid. Otherwise, you cannot connect this system to the grid itself. Now, this table here shows the summary of the load, battery, charge controller, inverter, okay, and everything here. Now, one more time here, we don't like to go in deep in mathematics, but here I gave you an example how things are calculated. Okay, of course, detail, and we have some courses in the department by which we can explain those steps in details. Okay, now what about our students' success stories? We have many success stories. Of course, here we are focusing on the renewable energy field. We won the first place in the Innovation Week in the UAE. From that prototype, we applied for a patent, I mean US patent, and it was approved and published last year. So that means we can get from the students' work something really we're proud of. And also we participated in very prestigious competition, which is called the Future Generation Competition, funded by the Middle East Electricity Awards. And we won the first place in 3 years in a row, which was a huge success. So here we won it under the project, which is called the Design and Analysis of Solar Updraft Tower. And for the second year, we won again the first place for the project. By the way, we won 2 places, the first place and the second place, because we participated in 2 projects. So the first place was the photovoltaic energy for seawater desalination in the UAE. And for the third year, again, we won the second place. And the project was called the Viability Study of Photovoltaic Systems Floating on Water Surfaces in the UAE. Okay, and those are those are our students who participated in the competition and won the competition. And also in the next science here, we got the first place under the project which was called Autonomous and Sustainable Sea Cleaning Robot. By this, we conclude this webinar. Thank you for your listening and patience. So if you have any questions, it will be my pleasure. So, Ms. Rina, is there any question? Ms. Rina?
Dr. Anas?
Yes, please. Yes.
You're done?
I'm done. Yes, I'm done.
Yeah. Do you want me to stop the recording?
Yes, please. Yeah. Stop.
Yeah, sure, definitely. I will end the webinar. I will end it. Thank you.